In this video, we're going to start looking at how to do gas law calculations. I just want to give you a quick review of how we came up with the gas laws, and then we will go ahead and do a little practice. So if you're pretty comfortable with where you got your notes in class about this, then skip ahead to the part where we start the practice problems. If you missed this, these are the equations that you need. We know that pressure is equal to some constant times temperature when volume and N, the moles of gas, are constant. We know that pressure is equal to some constant times the moles of gas at a constant volume and temperature. And we know that pressure is equal to some constant over volume. It's inversely related to volume at a constant number of moles and temperature. And so if we set that all up in one equation with pressure, we know that pressure is equal to some constant times NT divided by V. And so we can set that up as the ideal gas law. This is the equation that was just on the bottom of the page. We use the constant called R, and that's on the front page of your reference tables. It's called the universal gas constant. So when we substitute R in, we get P equals nRT divided by V. We rearrange it and it's PV equals nRT. That's the ideal gas law. Some people call it the pervert equation, but I don't call it that. But if it helps you remember. So R is the universal gas constant, and it has the four values you see on the screen. Those are all on your reference table, and remember that you'll choose the correct value based on the unit of pressure that's in your problem. So all of the other units in there are the same. So always choose the R based on the pressure units in your problem. The other equation that we use is the combined gas law. So if we have a sealed container, we know that the number of moles of gas is constant. And so PV is equal to some new constant times T. R is not part of it. And so if we set that constant, get that constant by itself, it's PV over T. And no matter what we do to a gas, that ratio will remain consistent. So what we can say is the ratio from one situation will equal another situation, as long as the N stays the same, the number of moles. So we can say that P1V1 over T1 equals P2V2 over T2. So with the same number of moles of gas, the pressure, volume, and temperature ratio will be the same as another pressure, volume, and temperature ratio. So it just is a matter of reading the problem and now figuring out which gas law to use, and then putting the variables in where they belong. So let's look at some gas law calculations. Our first one, this is pretty straightforward. Read through the problem and think about which equation would be the best one to use. That's always the first step in these gas law problems. We want to figure out whether there are multiple conditions or just one set of conditions. What I like to do is just go through and label the problem. So I label everything, and based on your units, you should be able to tell that liters is a volume, 8.92 moles is your N. Remember that N is your moles, or your amount of gas, and then 25 degrees C is a temperature. So we've got a volume, a temperature, and moles, and then we're being asked to find P. You want to look and see, are there more than one pressure, volume, or temperature? And there's not. Also, this equation has moles in it, which is a good indicator that it might be the ideal gas law. So we're going to use PV equals nRT. Make sure you know where this is on your reference table so that you have to use it. Let's rearrange to solve that for P. I'm going to divide both sides by V. And then we can just plug our numbers right in. So we have P equals nRT over V. All right, so just go ahead. We've got everything labeled now, so we can just pop it right into the equation. 8.92 moles. And then R, the R that we're going to choose is the one that belongs with the same unit of pressure that is in our problem. And if you can see, I gave you kilopascals. That is my unit that I want in the answer. So look at your R on your reference table, and you should find that it is 8.314, And the unit on that is liters times kilopascals over mole K. All right. Now remember that for all gas law problems, you will always convert your temperature from C to K. So we're going to add 273 to that, and that's going to give us 298 K. So we'll go ahead and put that in our problem. And then our volume, you want to make sure that's in liters, and that will be 20.0 liters. And let's go ahead and cancel our units. We've got moles here and moles here, liters here and liters here, K here and K here, and we're left with kPa, which is our pressure unit. And then when you punch that into your calculator, you're going to get a kind of an odd number. Remember that we have to think about sig figs. We've got 3 here, 3 here, and 2 here. When you go to round that to the correct number of sig figs, it'll be 1100 kilopascals. So it has 2 sig figs like the temperature. Let's try another one. So read through the problem, go ahead and identify all of your variables, and then we'll figure out what equation we're going to use. Remember, we need to figure out if there is one set of conditions or if there are 2. So looking at this, I see a volume. Liters is the unit of volume. Atmospheres is a unit of pressure. And then it says it's a temperature of 19 degrees C. It's asking me for a volume, and it's also giving me a pressure, and it's telling me it's at the same temperature. So looking at that, I have 2 volumes, 2 pressures, 1 temperature, and we'll talk about what to do with that. But clearly we have more than one set of conditions. So the best equation to use will be the combined gas law, which is P1 V1 over T1 equals P2 V2 over T2. And when you try to figure out which one should be P1, which should be T2, that sort of thing, remember that it's not really important which one you pick, which set of conditions you pick as the set 1 or set 2. The important thing is keeping the right things together. So if you read this, you've got a 50-liter cylinder of argon gas at 19.8 atmospheres with a temperature of 19 degrees C. So if I call this volume V1, I'm going to call this P1 and this T1, which makes this volume 2, the one that we're going to find. This is P2 and this will be T2. Now, one thing to think about, we just need to make sure those things are paired up. We want to go ahead and solve for what we're trying to find here. So we're going to solve for V2. If we want to get V2 by itself, we're going to have to multiply both sides by T2. And then we are going to have to, those will cancel, and then we'll divide by P2. And then these will cancel. And we'll be left with V2 equals T2 P1 V1 divided by P2 T1. And then we can just go ahead and put in our information. Now remember, with temperatures in any gas law problem, we want to add 273, and what I got for that was 292K. So 292K, and then P1 is 19.8 atmospheres, and V1 is 50 liters. Remember that T2 and T1 are the same, so we can come down here and put our T1 as 292K also. And then our P2 is 0.0974 atmospheres. Now you're probably noticing that when the temperatures are the same, you can just go ahead and cancel those. And you can actually do that at the equation step if you're comfortable doing that, because that will just save you a little extra math or extra solving. So when you go ahead and put that in, what I got was, I got 1016 on my calculator, but if you look, you only have 3 sig figs here. So we want to give an answer that has 3 sig figs. So I'm going to round that to the correct number of sig figs. Remember that 1016. These 3 are significant, so we're going to use this to round this, so that would make this 1020, and you can see atmospheres cancel and we're left with liters. So the pressure decreased. It went from 19.8 atmospheres to 0.974 atmospheres. The volume increased, and that's correct. So you want to think about what you would expect to see based on the relationships that you know from the work that we did in class. All right, let's try another one. Okay. So you saw in class the bell jar on the vacuum pump. That's the glass jar. And it says in this problem that the vacuum pump is reversed, so that rather than decreasing the pressure in the bell jar, it actually increases from 0.987 atmospheres to 3.5 atmospheres before the bell jar explodes. And it's asking for the volume of a balloon in the bell jar before it explodes. So let's go ahead and start labeling everything. You pause and do that, and then see if you can figure out which equation to use. If you think you know, go ahead and try the problem. All right? So let's plug in. I've got milliliters, so that's going to be a volume. And I'm going to look back through, and I've got a pressure here, and then I've got a pressure here, and I'm being asked for a volume. Now looking at this, there's no information at all about temperature. So let's kind of look at this and see, do you think this is one set of conditions or 2? I see 2 pressures and volumes, so I think this is 2 sets of conditions, which means that we're going to use the combined gas law. So that's going to be P1 V1 over T1 equals P2 V2 over T2. It does not mention temperature in this problem. It's talking about just a vacuum pump, so I think it's safe to assume that in this problem everything is happening at room temperature. So we can just go ahead and cancel temperature. There's not a temperature change. And so we can just cancel that out. It makes life a little bit easier. So now we've just got P1 V1 equals P2 V2, and we just need to figure out what we're going to solve for. So let's call this V V1. So the balloon starts at 550 milliliters, and then it's placed in a vacuum pump so that the pressure increases. So the pressure begins at 0.987, so that's going to be P1. And then this is that second pressure. This is going to be P2 because the pressure increases to 3.5. So we're actually going to solve this one for V2. So let's go ahead and divide both sides of this by P2 to get it by itself. And these will cancel, and V2 equals P1 V1 over P2. And we're going to go ahead and just plug that into the equation, everything from our problem. So P1 is 0.987 and V1 is 550 milliliters, and P2 is 3.50 atmospheres. I forgot my unit here. All right, so my units will cancel. I'm left with milliliters. It's okay to leave the volume in milliliters as long as you have nothing that needs to cancel. When you have an ideal gas law problem, you will want your volume to be in liters. But for combined gas law, as long as you need no particular unit in your answer, you can leave it in milliliters. So when I punched that into my calculator, I got 155.1 milliliters. But you can see that I only have 2 sig figs in this problem. So you should have an answer of 160 milliliters. If you gave that to me in liters, that would be fine as well. All right, I'm going to let you try the next problem. So go through, label the problem, set it up, and give it a try. This one's a little bit of a challenge, so we may need to talk through a few things, but see what you can find and see if you can figure out which equation to use. So here we have a volume and a pressure and a temperature, and it's asking the maximum amount of gas. So what it's asking for is N. Okay, so I've got one pressure, one volume, one temperature, and I've got moles of gas. So that one's going to be ideal gas law, PV equals nRT. Now, though, you notice it's got a conversion factor here. We've got PSI in our equation, and we don't have an R, a constant, the universal gas constant, with PSI in it. So we're going to have to take a step of calculating our pressure in atmospheres. So I'm going to come over here and do that. So I've got 80.0 PSI. And this is just a straightforward factor label conversion. So PSI on the bottom to cancel, atmospheres on the top, and then just take the numbers from our little equality down there. 1 atmosphere is 14.7 PSI. And so when I put that in my calculator, I got 5.44 atmospheres. My PSI will cancel here. So let's go ahead and plug that in. I'm solving for N, so I'm going to go ahead and divide both sides by RT. A little algebra there for you. Those will cancel, and I'll have N equals PV over RT. So let's go ahead and plug in what we know from our problem. Our pressure, we've converted from PSI to atmosphere, so that's 5.44 atmospheres. Our volume is 29.0 liters. And then our universal gas constant, look at the ones on your front page and pick the appropriate one. Hopefully you chose 0.0821 liter atmospheres over mole K. That's a heck of a unit, isn't it? And then we're going to go ahead and put in our temperature. Remember that with our temperature, we're going to add 273 for all of our gas law problems. And that's going to give us 378 K. So I'm going to plug that in. Then it's plug and chug. So put all these numbers in your calculator. Remember, atmospheres will cancel, liters will cancel, K will cancel, and we'll be left with moles, which is the answer that we're looking for. And when you punch those numbers in, you should get 5.08 moles of gas. All right, let's try another one. All right, so this problem is a little bit different. Let's label everything and then we'll talk through it. So we've got a volume, we've got a pressure, and we've got a temperature. And it's asking me for mass. There's no variable for mass in either of our gas equations. But hopefully you're looking at that and thinking, well, if I know the moles, then I can calculate the mass because I know what the gas is. Okay? So I have if I can find the moles of the gas, I can use the ideal gas law to do that, one set of conditions. I can find my moles. I know that it's nitrogen. I can use the molar mass of nitrogen to convert it to grams. So let's go ahead and find that one. So PV equals nRT. And again, we're solving for moles, so we're just going to divide both sides by RT. Those will cancel, and we'll have N equals PV over RT. And so our pressure is 15,500 millimeters of mercury. That sounds really high, doesn't it? And then our volume is 3.25 liters. And then the R that we choose, remember that should be the R that has the correct unit of pressure here, millimeters of mercury. So you should choose 62.4 millimeters of mercury, and then liters over mole K. And then don't forget with your temperature to put in 298 K. This will add 273, and that'll be 298 K for our temperature. This step where you cancel your units, the millimeters of mercury cancel, the liters cancel, the K cancel, this will help you catch that step if you forget to convert your temperature. That is a really common mistake that I see when students take tests. And my bet is that that's one of the answers that they put on your exam. All right. When I plugged this in, I got 2.709 moles of nitrogen. Remember that we don't care about sig figs at this point. It's not our final answer. The other thing that's important to remember is our formula for nitrogen. Hopefully you're remembering that nitrogen is diatomic, so it is N2. And then it's just a matter of going from moles of nitrogen to grams of nitrogen using our molar mass of nitrogen. Remember that because we want the moles to cancel, we'll put those on the bottom, grams of nitrogen on the top. Because it's N2, it will have a molar mass of 28.02 grams. When you put that in your calculator, you should get 76 grams of nitrogen. I'll look forward to seeing how you're doing on these when I see you in class.